So hello, future engineers, subscribers, viewers, and students. So here are another problems in calculus. I hope that you will improve through these problems. If you want to anticipate the solution to this problem, you may do so by pausing the video. The graph shows how the average age of first marriage of Japanese men varied in the last half of the 20th century. Sketch the graph of the derivative function m prime of t. During which years was the derivative negative? So sorry for the tangents that move a little. So they are intended at the highest points. That's why m prime is 0. Supposedly there at this lowest point m prime is 0. Then this is at this point somewhere here, which is 0.1. And we have m prime 0.05 and m prime decreases, but it's still greater than 0. This m prime here, the estimates here would be interpreted as ordinates or y coordinates of the graph of m prime of t. So let's project it downward. So this is about 0.01, so that's why you have 0.01 at that year there. Then it decreases, the slope decreases until 0 somewhere here, which is about 1963. Then the slope is negative in this interval up to around 1971. So that's why we have negative coordinates here for this part. Then the slope again begins with 0 and it increases up to this, which is the highest is 0.01 again, 0.1 rather. Then it decreases. So we have m prime, which is 0.05 somewhere here at this here, and it decreases, but it is still positive, so above the t-axis, horizontal t-axis. So this is the graph of m prime of t, and to answer this question, during which years was the derivative negative, so that is approximately between 1963 and 1971. So that's my answer, although it should be drawn accurately so that you will agree with that answer. So let's proceed to the second question. Let f of x equals x squared. The graph y equals x squared is a parabola open upward. Estimate the values of f prime of 0, f prime of 1/2, f prime of 1, and f prime of 2. By using a graphing device to zoom in on the graph of f, use symmetry to deduce that the values of f prime negative 1/2, f prime negative 1, and f prime negative 2. Use the results from parts A and B to guess a formula for f prime of x. Then use limits to prove that your guess in part C is correct. So for f prime of 0, it is 0 because the tangent at the origin is horizontal. So that's why f prime of 0 is 0. F prime of 1/2, which is here, 0.5. So that's 0.5, 0, so 0.5 height. This is 0.75, this is 0.25, 0.75 minus 0.25 is 0.5. Rise 0.5, run 0.5, and that's positive slope, so 0.5 over 0.5 is 1. So f prime at 1/2 is 1. F prime of 2, so this is 1, and that's 0.25, which is this. So 1 divided by 0.25, so that's why f prime of 2 is 4. 1 over 0.25 is 4. Then for part B, by symmetry, here f prime of 1/2 is negative 1, the negative of this value, because that's negative, and the graph of the parabola is symmetric with respect to the y-axis. F prime of negative 1 is the same here but negative, so it is equal to negative 2. Then f prime of negative 2 is also negative 4. So by guessing, because we notice that the slope doubles, therefore we guess that f prime of x is 2x. So that's the formula, because x is 1/2, the slope is 1. At x is 1, the slope is 2, so which is times 2. So 2 times 1. So 2 times 1 half is 1. 2 times 1 is 2. And 2 times 2 is 4. So that's why the guess is f prime of x is 2x. Then we have dy dx. This is f prime of x is the limit of delta y over delta x as delta x approaches 0. So we write y plus delta y. Y plus delta y equals quantity x plus delta x quantity square. So delta y is equal to quantity x square plus 2x delta x plus delta x quantity square, then minus x square. Simplifying, so we can cancel x square, so we have 2x delta x plus delta x quantity square. So delta y over delta x, divide everything by delta x, is 2x plus delta x. Then dy dx is f prime of x, which is the limit as delta x approaches 0 of this expression left. So when delta x approaches 0, dy dx, which is f prime of x, is indeed 2x. So our guess is correct. So that means we have correctly guessed f prime of x. So we have the tangents here. So for the next problem, let f of x equals x cubed. Estimate the values of f prime of 0, f prime of 1 half, f prime of 1, f prime of 2, and f prime of 3 by using a graphing device to zoom in on the graph of f. So similar to the preceding problem. Use symmetry to deduce the values of f prime of negative 1 half, f prime of negative 1, f prime of negative 2, and f prime of negative 3. Use the values from parts A and B to graph f prime, then guess a formula for f prime of x. Use limits to prove that your guess in part D is correct. So first, let's sketch the graph of f of x equals x cubed. If you're experienced, it looks like this. So this is the graph of f prime of x. So that's why at the origin, the tangent is horizontal. So f prime of 0 is 0 at the origin. Then at x is 1 half. So let's zoom in this part here. So this is the zoom portion so that we can estimate the slope of the tangent here. That part there. So 4 over 1.33. 1.33 horizontally, then 4 vertically. So at 1 half, 0.5, we have 1/8 for y because 1 half quantity cube is 1/8. Then it intersects with this, which is estimated to be 0.5, and the horizontal is around this is 0.5 minus 1/8, then the horizontal is 0.5. So that f prime of 1/2 is rise 0.5 minus 1/8 divided by 0.5. So f prime at 1/2 is 3/4. Then f prime at 1, when x is 1, somewhere here, we have 4 over 1.333. So that's about 3. Then f prime at 2 here. So that's the tangent. So this is 20 minus 8. So 12. Then this is around estimated to be 0.55. So f prime at 2 is 12 over 1, because this is 1, 2, 3. So 12 over 1. So 12, while f prime at 3, which is here, so that's around 15 over 0.55. F prime at 3. 15 over 0.55, so around 27. Then, because these are interpreted as ordinates to the graph of f prime of x, which is this, and by symmetry, the slopes to the right would be the negative of the slopes to the corresponding points at the left. So that's why f prime of negative 1/2, which is here, is f prime of 1/2 should be negative 3/4. This is f prime of negative 1/2. So it is positive 3/4. It's the same. Sorry. We have positive slope also in this part because it is in this portion here. So the slope of the tangents from here to the left, then up to 0 is positive, decreasing until it is 0. So f prime at negative 1/2 is the same as f prime of 1/2, which is 3/4. F prime of negative 1, which is the same as f prime of 1, which is 3. F prime of 2 is the same, 12. F prime of negative 3 is the same as f prime of 3, which is 27. So that's why this would be the plot of f prime, the graph of f prime. Then part C, use the values from parts A and B to graph f prime. So this is now the graph of f prime, all positive. It is parabolic because of same slopes at corresponding points, left and right. Then part D, guess a formula for f prime of x. So to guess a formula, part D, it is equal to 3x squared. The graph is 3x squared. So f prime of x is in general kx squared at 1, 3. X is 1 and y is 3. So k is 3. So the graph would be y equals k, which is 3x squared. Then another point would be at 12, 2, 12. When x is 2, the slope is 12 in our guess here, from our guess. So k is also 3, just to check that for the selected points, the value of k is the same. So thereby, our estimates for the slopes are correct. So therefore, f prime y, which is f prime of x, is indeed 3x squared. So this is k3 and x squared. Then use limits to prove that your guess in part D is correct. So this is now part E. Y plus delta y equals quantity x plus delta x cubed So delta y is x cubed plus 3x squared delta x plus 3x quantity delta x squared plus delta x cubed minus x cubed. So cancel x cubed. So delta y equals 3x squared delta x plus 3x delta x squared plus delta x cubed. Divide everything by delta x. So delta y is 3x squared plus 3x delta x plus delta x squared. So dy dx is f prime of x, and that's the limit as x approaches 0, so that's why it is 3x